All right, guys, so today we're actually learning something new, okay? We are starting Newton's law. So if you look down here, learning intention, we are learning to investigate and describe applications of Newton's three laws of motion. So you might have heard of Newton's laws before. We're going to focus on the second law, okay? So we're going to skip around. We're going to learn about the second law first. So the two things you need to be able to do is describe or model the relationship between force, mass, and acceleration caused by an unbalanced force, and then calculate force using the formula F equals ma. So today we're going to focus a lot on this last one right here, which is using the formula. Now, when I get back, these are the notes we're going to glue into our notebook. But here, again, we're looking at Newton's second law. It's the law of force and acceleration. And basically, what it means is in order to calculate acceleration, you're going to need to take the force of the object and divide it by the mass of the object. So there are three different ways that we can calculate for force, mass, and acceleration. We can do force equals mass times acceleration. So taking the force, solving for the force, you'll take the mass and you'll multiply it by the acceleration. If you need to solve for mass, you'll take force divided by acceleration. So this will go first in your calculator and then the acceleration. And then acceleration, if you're solving for acceleration, you'll take the force and you'll divide by the mass. Okay, so these are the three formulas. Now, when you're reading problems, they'll give you a hint and they'll give you the units. So force is measured by newtons, mass is measured by kilograms, and acceleration is measured by meters per second squared. So you should remember that we talked about this in the first part of this unit when we looked at speed, velocity, acceleration. And then this down here is just common sense. A larger mass requires more force. A small mass requires less force. So for example, pushing a big old truck is going to require more force than pushing a bike, okay? Large mass has less acceleration, small mass has more acceleration. So something with a small mass is going to have a large acceleration, move faster, move quicker, versus a large mass is going to have a smaller acceleration. It's not going to have the same acceleration. It's not going to move as fast as something with a small. So now that I've kind of given you an overview, please answer this question.